So first we will see introduction of data structure. Any good programming language course does cover data structure, means each and every programming language, means the good programming language like C++, Java, all contain data structure. So in every good programming language data structure is present like C++, Java, Python, etc. A data structure in general refer to a particular way of storing and organizing data in a computer. Means the meaning of data structure is what? It refer to particular, means it is mainly for storing and organizing data in a computer so that it can be used most efficiently to give optimal performance. Means if the data is properly organized and stored, then it will increase the performance. Different kinds of data structures are designed and used for different kinds of applications. Means there are different kind of data structure and each data structure is used for single or different kind of applications. The significance of data structure lies in the fact that they help a computer performance task in most efficient and productive manner. Some data structure are highly specialized to specific tasks like stacks and queues. And such data structure in this chapter we shall be talking about the basic of this data structure and how this can be implemented in Python, means how we can implement stack and queue in Python. First, stacks. A stack is a linear structure implemented in LIFO. Means the full form of LIFO is what? Last in, first out manner, where insertion and deletion are restricted to occur only at one end. Means stack top. So what is stack? Stack is a linear structure implemented by LIFO. Means it use the technique. Means stack use the technique. The name of technique is what? LIFO. The full form of LIFO is what? Last in and first out. In this, insertion and deletion take place from only one end. Means from one end insertion and deletion takes place and the element which is inserted first will remove at last and the element which is inserted at the last will remove first, because in this it used the technique last is first out and insertion and deletion takes place from one end, means the stack top. So LIFO means what? Element last inserted would be first one to be deleted. Why? Because insertion and deletion both take place from one side. Thus we can say that stack is a list of data that follows this rule. Number 1, data can only be removed from top. The top is known as pop. Means the stack follow these two rules. First is what? Data can only be removed from top, the element at the top of the stack. The removal of element from stack is technically called pop operation. Means when the element is removed from stack is known as pop operation. Number 2, a new data element can only be added to the top of the stack. The insertion of element in a stack is technically called push operation. Means when the element is added in stack is known as push operation. So insertion means the adding of element and removing of element both take place from stack top, means at one side. Consider figure 10.1 that illustrate the operation push and pop on a stack. Means see this diagram, this complete diagram. In this, see, at the beginning the stack is empty. The stack is empty. So top will means top assignment none. Means what? If the stack is empty, so there will be no element. So at top there is no element, that is why top is none. After that, see here, B, push 32. Push means what? We are adding an element to a stack. So in this stack 32 is added. So the top of stack is what? 32. Next again we are writing what? Push 18 means we are adding one more element, 18. So now the top will change. Previously the top was 32, now the top will become 18. And you can see here the element is added from one side. Next, pop one element means we want to remove one element from the stack. So if one element is removed, so the top element will be 32, means 18 is removed, that is why the top will become 32. Next, push 29 means we want to add 29 in the stack, so 29 will come and it will become top. Again, pop one element means we want to remove one element from stack, so 29 will remove, now top will become 32. Means push means what? We want to add element in stack. Pop means we want to remove element from stack. Notice all stack operations, push or pop, take place at one side. Means stack top means from here, means the element is added from stack top and element is removed from stack top, means from one side. The stack is dynamic data structure. Why? Because the size can be increased or decreased, that is why the stack is a dynamic data structure, as it can grow with increase in number of element. Means when the number of element is increasing, the stack size is increasing. Or shrink with decrease in number of element, means it will decrease when the element is removed from the stack. So stack, that is why stack is dynamic data structure, means that size is not fixed, it can increase when the element is inserting inside the stack, or it will decrease when the element is removed from the stack. So a static data structure on other hand is the one that has fixed size. Stack is what? Dynamic means it will change, but static data structure means what? The size will be fixed, it will not increase or decrease. Other stack terms. There are some other terms related to stack, such as peak, overflow and underflow. So first we will start peak. Peak refer to inspecting the value at the stack top without removing it. Means whenever we want to find that which element is present at the top of stack, that is why, means that will refer to as peak. Here we are inspecting, means we are identifying which element is at the top without removing. Here we are not removing the element, but we are finding which element is at the top. Then this process will known as peak. It is also sometimes referred as inspection. Next is overflow. Refer to situation error when one try to push an item in stack that is full. Means overflow is a situation, means it is an error and it is a situation. It occurs when someone try to push some element inside the stack which is already full. Means when the stack will full, no new element will be added. That is why it is known as overflow and it is an error. So when the stack is full and we are trying to add new element inside the stack, then this type of situation is known as overflow. This situation occurs when the size of stack is fixed and cannot grow further, or there is no memory left to accommodate new item. Means when there is no space or stack is full, but if we are trying to add some element inside stack, then this type of situation is known as overflow. Means no new element will be added to the stack because stack is already full or no memory space is present. Third, underflow refer to situation error when one try to pop, means what, delete an item from an empty stack. So underflow is also a situation, means it is an error. It arises when someone try to delete or pop some element from the empty stack. If the stack is empty, means there is no element, but if we are trying to remove any element, then this type of situation arises is known as underflow, means there is no element. And how we can delete if the stack is empty? Stack is empty means there is no element, but still we are trying to remove the element. So this type of situation is known as underflow. That is, stack is currently having no item and still one try to pop an item. Consider some examples illustrating stack functioning in limited size stack. Please note, we have bound fix the capacity of stack for understanding purpose. Example 10.1, given a bounded stack of capacity 4, means this particular stack will contain 4 element which is initially empty. Draw a picture of the stack after each of the following step. Initially the stack is empty, means at the beginning the stack is empty and we have to add total 4 element. So see the first one, stack is empty, means this one. Number 2, push A, means we have to add an element A inside the stack. So when the stack is empty, at the top there will be nothing, but when we are adding element, means we are pushing a element inside the stack. So stack, previously the stack was empty, that is why top none. Next, when we are pushing A, so see this one, means at the beginning stack is empty, so at the top no element will be there, that is why we will write none. This is the diagram of empty stack. After that we are writing what, push A, means we want to add element A inside the stack. So we are writing A inside the stack, and the indexing, means positive indexing will start from 0. So first we will write 0, then 1, then 2, then 3. So we are adding A. So now A will indicate what, top 0. 0 indicate what, index number. So see here, A is present at index 0, that is why we are writing here push A, means we are adding A inside stack. So A is coming here, then top equal to top assignment 0, means this is index number 0, means at index 0 A will inserted. Next, push B, then top will change from 0 to 1. Previously A was present, now we are adding B, so top will change from 0 to 1. Next, push C, top will change from 1 to 2, means A is present, B, then C, means as the element will be inserted inside the stack, the top will also changing. Previously it was 0, then 1, now it become 2. Next, see here, pop top assignment 1, means we are pop means what, we have to remove one element. So the element which is present at the top will removed. So at the top C is present, so C will removed. So now top from 2 it will come to top 1. Why? Because top, see here, C is present. When C is present inside the stack, then top is 2, but when C will remove, the top will change from 2 to 1. Again push D, so we have to add D inside stack. So now again the top will change from 1 to 2. So like this, 0 is inserted, means A is inserted, then B, then D. So when the element will insert, the top will also change. Previously 0, then 1, then 2. And insertion start and means we can insert or delete item from one side, means at stack top. This is stack top. That is why see here element is inserted like this, first A, then B, then C, then D, like this. So top is changing from 0, 1, 2 and 3. Again pop top 1. So D will remove, again top will change from 2 to 1. Again push E, means E will added inside the stack. Now top will again change from 1 to 2. Again push F, then top will become 3. F is coming here, then top will become 3. Again see here push G, then top 3. See here the size of this stack is 4, means it this particular stack will contain only 4 element, and 4 element is already completed. Again, but we are again trying to add one more element, then overflow will come, because the size of this stack is completed, means this particular stack is full, no new element will be added. That is why overflow will occur, means this is an error. So G will not added to this stack. Overflow because the stack is bounded, it cannot grow. If it could grow, then there would be no overflow until no memory is left. This particular stack is bounded to 4 element, that is why this overflow condition is arises. In Python, for stack implementation through list, since list can grow, overflow condition does not arise until all memory is exhausted. Means if we are not bounded this particular stack to 4, then the overflow situation will not occur. It will goes on until the memory space will complete. But here we have fixed the size of stack, that this particular stack will contain only 4 element. That is why overflow condition is arises. But if the size of stack is not bounded, then it will goes on until all the memory space will full or completed. Again pop, then top 2, means we have removed F. Pop means what? Remove. We are removing F, then the top is coming 2. Again see here pop means remove one element, so 2 is removed, then again top will become 1. Why? See here E is removed, that if E is present then top is 2. E is removed, then the top element will become B, so we will get top 1. Again see here pop means we have removed this element B, so top will move to 0, means it will change from 1 to 0. Again pop, top will none. Why? Because only this is last element and we have removed this element A, so now top will become none, means at top there is no element present. If again we are writing pop, then underflow condition will arise. Why? Because see here all the element is removed from the stack, now stack is become empty, but we are trying to remove element, then underflow situation will arise. Implementing stack in Python. In Python you can use list to implement stack. Means how we can implement stack in Python program? With the help of list. Python offers us a convenient set of method to operate list as stack. For various stack operation we can use list say stack and use Python code as described below. Means first pick, so we can use stack top. Stack means what? It is a list, and top means what? It is an integer. So For this, the meaning is what? Where stack is a list. Top is an integer having value. The value of top is what? Len. Len is a method, and inside len we have written the list name minus 1, because in list positive indexing start from 0. For push, we can use stack dot append, because we use append method in list to add one element at the last at a time, means we will add one element at a time at the last, so we will use append method. So push means what? We want to add one element at the last, because insertion and deletion in stack take place from one side, stack top, so we will use append method. So item is an item being pushed in a stack. Item is the element. Next, pop. We can use stack dot pop. Pop, we use pop method in list to remove one element at a time. So it remove the last value from stack and returns it. So let us now implement a stack of number through a program. Means we have created one function. The function name is what? Push. Means so we will write what? Def push stk comma item. Program 10.1, Python program to implement stack operation. So see here, stack implementation. After that, see multi-line comment, stack implemented as a list, top integer having position of topmost element in stack. After that, we have created one function. This is built-in function. So first we will write def, means this is function header. After that, is empty. Is empty is the name of the function, and in parentheses we have written stk, then colon. Inside this function we will write if stk. Stk means what? List. So if list equal to this square bracket, means this indicate what? In list this indicate empty list. So we are writing the function. This is function header, means def, the name of function is what? Is empty, and inside parenthesis we have written stk, and after this parenthesis we have written colon. So here we are checking the condition after writing the conditional statement. See here, if stk is the list name, list, after that equal to this is square bracket. Square bracket indicate what? Empty list. If condition is true, then return true, or else return false. Means first we will check that this particular stack or list is empty or not, and after that we will start adding element inside the stack. For that we have created one more function, def push. The name of function is what? Push, and this is function header. So we will start with the keyword def, and inside parenthesis we have written stk comma item, and at last colon is written. Inside function we have written stk. Stk is the list name or stack name. After that, dot append, we are writing append method, and inside append we have written item. Item is the element which we want to add inside that particular stack. So we will write stk, the stack or list name, dot append method, and inside parenthesis of append we will write the element which will be added. After that, see here, top is given. We will write top assignment, then len stk minus 1, means top will contain what? Len is what? Length function. It will return the count of the element. See here, stk is the list name or stack name. We have written inside len parenthesis, so it will return the size of stk, and minus 1 indicate what? List list indexing start from, means positive indexing start from 0. That is why we have written minus 1 here. So all this will store inside top. So top equal to what? A top assignment means this all will store inside top. So we have written this function header, means first we have checked that this particular stack is empty or not. After that we will start adding element inside the stack. So we have created one function. The name of function is what? Push. And inside push function we have written stk comma item. Stk indicate what? The list name or stack name. And we have written what? Dot append method to add the element. Then item inside parenthesis means the item which will be added. And after that we will see top. Top content what? Len stk minus 1. Len is a method, and inside this method we have written stk means the list name. It will return the count of element which is present inside stk minus 1, because in list positive indexing start from 0. So in this way we will add element inside the stack. For removing element from stack we will create one more function. The name of function is what? Pop. So we will write this function header means def pop stk. After that colon we will write. Stk is the list name or stack name. So we will check the condition. What? If is empty, stk colon, then underflow. Return underflow means what? If the list or stack is empty, then it will return underflow. Pop means what? Means to remove the element from the stack. But if the stack is empty and still we are trying to remove the element, then it will return this message. What? Underflow. Or else item assignment stk dot pop means if the stack is not empty, so this else part will run. It contain what? See here, item assignment stk dot pop. Stk means the list or stack name, dot pop means to remove the element, means the top element of stk. So we have written here pop, and this all will store inside item. After that we have written what? If len stk double equal to 0, then top assignment none means if the length is what? The length of stk double equal to 0 means if the means after removing the element the length is returning what? 0. So the top will become none. Means in this condition here we are checking what? The list is empty or not. If the list is empty, it will return underflow. Here we are checking what? Here we are removing the element from the stack. For example, understood, see here, if this stack contain only one element, and after pop it will return what? None. Means here we are checking the condition that list is empty or not, means the stack is empty or not. If the stack is empty, it will return underflow. But here we are checking, means here what? See here, means this particular stack contain only one element, and after the pop method it will remove that element. Then after removing that single element from the stack, it will become 0, means there will no element present inside that stack. That is why it will known as stack double equal to 0, means it will return what? Top will become none. Once again I am explaining. See here, here we want to remove the element from stack. For that we will use pop. So here we will provide certain condition. First we will check that this particular stack is empty or not. If this particular stack is empty and still we are trying to remove the element from this stack, then it will return underflow. This is first condition. In second condition, that particular stack is containing only one element, and after the removing of that particular single element, what we will get? Means we will get top none. Why? Because this stack is containing one element, and after removal of that particular element the top will become none. Means stk is the stack name equal to 0, then top will become none. Here the stack is containing one element, and after using pop that particular element is removed. So if that particular element will remove, then top will become none. And this is third condition. What else? Top assignment len stk minus 1 return item. Means in this condition that particular stack is containing 2 or 3 element and one element is removed, then the remaining, if here if 3 element is present in stack and we have removed one element, then here the top will become what, 1, because positive indexing start from 0. So if 3 element is present and we have removed one element, then 2 element will left, then counting will start from 0, so 0 and 1, so the top will show what, 1. So here total 3 condition is there. First, no element is present. Second, only one element is present. Third, more than one element is present in stack. After that, for pick, means to identify which element is at the top without removing that element. So for that we have created one more function, def. The name of function is what, pick. Then we have written stk. Stk is the stack name, and inside this we have written what, if is empty stk, then it will return underflow. In pick, if the stack is empty, then it will return what, underflow, or else it will return top assignment len stk -1, then it will return what, return stk top, then it will return the top element. Means in pick, first it will identify that this particular stack is empty or not. If that particular stack is empty, then it will return underflow. But if the particular stack is not empty, then it will return the element which is present at the top, the index number, not the element. It will return the index number, like top 2, top 3, because indexing start from 0. In pick, it will only identify that at top which element is present and what is the index number. Here it will not remove the element from the stack in pick. And last, display, means first we have checked that the stack is empty or not, and after that we have inserted some element inside stack, then we have removed some element from stack, and after that we have checked which element is at the peak, and at last we will display. So for display we have created one more function. So this is function header, def. The name of function is what, display, then stk, the stack name, then colon. Inside this we have checked what, if is empty stk, then it will print empty stack. Now in display function we have to print, that is why we have used the print statement. So if is empty stk, then it will print that this particular stack is empty, or else top assignment len stk -1, this complete, and after that it will print what, print stk top. Stk top indicate the element which is present at the top. The value means the which, see this is not in quotation, so the top element will print, and see this is in quotation, means this one is in quotation. So if the element is like the, see here 1 and 2, so it will print output like this, means this is top element and this will print this arrow and top. And after that we are writing for loop for I in range top -1 -1 and -1. So see, when 3 item is present or 3 object is present, so it will become start, stop and step. So starting is what, top -1, step is what, -1, and stop is what, -1. And after that at last we will write the print statement. See, inside print we have written what, stk a. Stk is the stack name, and in square bracket we have written a. A is a variable. After that this comment line is there, means all the function were written in this particular program, all the function is written. So after function the top level statement start. So this comment line is given what, underscore main underscore, means initially stack is empty. See here, this one means previously till here all the function were written. Now we will write the top level statement. So this is comment line, and after that see stack assignment 0 means here it indicate what stack is empty. So if the stack is empty, then top will none. And after that we have written while true, then all this print statement is present inside this while loop. So it will all print on the output screen. What? Print stack operation, print 1, then push, print 2 pop, print 3 peek, print 4 display stack, print 5 exist. All this will, in this while loop we have written the condition true here. And after that see here, we will accept one input from the user. So this all the choices are given here, but we want to accept an input from the user. So we will write here, we will create one variable ch, after that int input, enter your choice. The range is what? 1 to 5 means total 1 to 5 is given here, and we want to accept input from the user, and after according to his choice we will perform the operation. So here we are accepting the input. This is variable assignment int input, enter the choice. This will print on the output screen. After that if ch is the variable double equal to 1 means this indicate what? If we are writing like this means it is equality operator. So if ch equal to 1 means ch is what? The variable means all this is stored inside ch. We are accepting input from the user and all this is stored inside ch. So if ch double equal to 1, so in 1, then if 1 is coming, then push will perform. So item assignment int input enter item, then push, we will call function push here, and after that stack and item. See here, if this condition is true means if ch equal to 1, then in 1 what is present? Push. So we will accept element which we will insert inside the stack. So item is an variable here, after that int input enter item, and after that here function call is there. Which function? Push. It contain two thing means two object. What? Stack, the name of stack or list, then item means the element which will be inserted inside that stack. After that elif what? Ch equal to 2. If 2 is coming means if user is providing 2, then pop operation will perform. For pop we have written here what? Item pop stack means after pop it will store inside variable item. We are writing here pop, and inside pop we are writing here what? Stack inside the parentheses. Then we will write the condition. If item double equal to underflow, print underflow stack is empty. Means if there is no element present, then it is equal to underflow. That is why this print message will print. After that else print popped item is item. In this print statement, popped item is this is in double quotation, so it will print on the output screen. After that item is there, so the value means the element which is removed, so it is not in quotation, so the item which is removed will print here like this. Elif if variable is what? 3 indicate what? 3 means peak, 4 will means what? Display stack, 5th means exist. Like this all this will perform. So when this particular code will run, we will get output like this. Means first this will print. Why this is printing? Stack operation. See here, the first print statement is what? Stack operation. That is why it is printing. So see here, multiple print statement is there. This all will print, and after that it will accept input from user, and according to that it will perform the operation. So all this print statement will print. means stack operation. Number 1 push, number 2 pop, number 3 pick, number 4 display stack, number 5 exist, and after that it will accept input from the user. So enter your choice from 1 to 5. Here user is providing 1, means push. See here, push is there at 1, so enter item, then user is providing 6. So in this particular stack 6 is inserted. After that this complete message will print, enter your choice. Again user is providing 1, enter item 8, means 8 is inserted inside the stack. Again this message will print, stack operation, all this. Here user is providing 1, enter item 2, means 2 is also inserted inside the stack. Again this will goes on, and here user is providing 1, means enter item 4 is also inserted inside the stack. See here, again this will goes on. Here user is providing 4. 4 means what? Display stack. So it will display all the element which is present inside the stack along with the top element also. See here, first we have inserted 6, 6 is coming here. Then we have inserted 8, 8 is also coming here. Then we have inserted 2, it is also coming here. And at last we have inserted 4. And this is also printing. The arrow top indicate that 4 is at the top. We have written this in quotation, that is why it is printing here. Again see here, this message will print. Here user is providing 3. 3 means what? Pick. Then topmost item is 4. It will return. Here is user is providing 4. 4 means what? Display stack. So that is why it is displaying. Here user is providing 4. 4 indicate what? Display stack, means it will display all the element which is present inside the stack along with this top. Here user is providing 3, means this will print. 3 indicate what? Peak. At peak 4 is present. See here, 4 is present, that is why 4 is coming here. Again this complete will print. Here user providing what? 4. Then this complete message is coming again. After that see here, this complete message is printing. Here user is providing 5. 5 indicate what? Exit. So it will exit. Like this we will get the output. One assignment is given below. You have to solve in your copy. Question number 1, explain data structures. Question number 2, explain stacks. Question number 3, write difference between overflow and underflow. Question number 4, explain implementing stacks in Python. Question number 5, write a Python program to add 3 elements in stack and remove 1 element from that stack. Means first we have to insert 3 elements inside the stack, and after that we will remove 1 element from that stack. Thank you.